Hello there. Today we'll be doing hit counter. Implement a hit counter which keeps track of numbers of the number of hits in the last 60 seconds. Add will take in a timestamp and which adds a timestamp in seconds in the hit counter. And count will return the number of hits that have been made in the last 60 seconds given the current time in the timestamp. You can assume that the timestamp passed into add and count are monotonically increasing. So that means that every number will keep on increasing. So once you hit 100, the next possible number must be greater than 100. And that means that we can never go back to a smaller timestamp. Back in time. Okay, so in this particular solution here, we added a hit at 10 seconds, at 40 seconds, and we did a count in the last 40 seconds. What we found was a 2. Then we added a 70 a count at 70, and we did a count at 100, and we found two counts. Because we found a count at 70 and a count at 40 because we have lost the count at 10. So that is a hit counter. So there are several methods that we can think of already that allow us to do this particular problem. One of which is to well, what we can do is create a list, and if we create a list and we store everything, and a problem with that is that how big is this list going to be, right? We could limit the number of items in that particular timestamp by let's say removing the items from the list. To speed things up, we could do a dequeue, and that makes our popping a lot easier. However, this would cause us to have a O of n space depending on the amount of counts or hits that we will get in the duration of 60 seconds. So we have to store a lot of hits. One way we could limit that number of hits instead of using a list for storing timestamps, we could have a list for each second in the timestamp. Whether it be 60 seconds or 300 seconds, it will be O of 1. With that, we are able to reduce the cost of our memory to 1. And we can also have a lookup time of 1. Right. So I think that would be the best possible solution for this particular problem if we were going to scale. However, if we wanted to speed things up and type all this code quickly, we'll run the O of n method. So I'm going to go through the O of n method very quickly, and then we will go through the O of 1 solution. So self.q equals dequeue, right? Then we need a cleanup function to clean up our queue. We need to look for all the items that are greater than 60. So we need a definition for adding. We're going to do the cleanup immediately. That way we make sure that we don't use too much space every time we add. And self.clean queue.append to timestamp. So this attaches more items to the stamp. So now we are going to do a count of the timestamp and self.cleanup of the timestamp. Return the length of self.queue. And that's all. Oh, cell is not run. Okay, perfect. And we have 54. If we reduce the amount of cleanups that we have, we can speed this up some more. So, in terms of getting speed, we sacrifice space because the data structure for the DQ is a lot faster. Right. So everything that's done in the cleanup is that we take the current timestamp that we've already hit, and we make sure that the earliest item is removed if it's greater than 60 seconds of that timestamp, because we don't need that anymore because we're not going to count that, and that's how we reduce the number of items in our queue. All right, so we're going to do the O of 1 solution now. So for O of 1 solution, we want to have a total of 60 seconds available, and we want to have a counter of 60 counts. 61 is to just make sure that we have that extra 1 second, 0 to 60, 61 seconds. Okay, so we don't need the cleanup anymore. And we just need to add the time. So to do this, we want to make sure that our index is equal to the timestamp modulus of 61. That gets us between 0 and 60 seconds. That gets us to all our indexes. So once we use that index, we don't really care about it. Like because when we look for items, we must meet that must be greater than our timestamp. So we can just throw all of our items into our timestamp, as long as it's we'll replace the timestamp if it matches the same index and has a different timestamp, and we'll hit the set the hits to 1. Otherwise, we're going to increase our hits because it's the same timestamp. We got the same index. That means we need to increase the hit counter and for that particular timestamp. Right. So here we go. For this one, we just need to create a counter. And we're going to count from I in range to 61 because of all 60 items, 0 to 60 seconds. If self.time of I is greater than or equal to the timestamp minus the 60, then it is within range. And we can total plus equals self.hits I. And then we can return the total. Submit. And it is quite slow, but we save so much space. Because instead of storing infinite number of hits within a 60-second span, we only store 60 hits. And this way we have an O of 1 space and an O of 1 time of collection. In the previous solution, we had an O of n lookup time because we had to remove, I don't know, n number of timestamps. So it is that was not feasible for if we were to implement this. in a in a real environment. So in this case, some of you might be wondering, why don't we have to remove the previous timestamps? Well, the line is the important thing, like I said before, was this particular line that allows us to just forget about the previous timestamps that have hits, because we're not going to count them anyways. We're only going to replace them when we need to. This line tells us that if and only if that particular time stamp at that particular index is greater than the timestamp minus 60 seconds, then we would count it. Otherwise, we'll just leave it around, hang around until we need to replace it later, as seen in this code here. And that is all for hit counter problem. Well, thank you very much for watching. If you enjoyed the video, like and subscribe. And if you have any questions, please comment below. Maybe someone will get to it. Maybe I can get to it. And if you would like to see more of my videos, please check out in the link in the description below. There will be algos and there will be iOS projects that I'll be working on. Thank you very much and have a good one.